Hey guys, it's Mr. Win, and we're going to talk about factoring polynomials. All right, so we factored before, we factored quadratics all in Unit 2, but now we're going to factor polynomials, right? So we'll have more than just quadratics. We might have cube roots, or, well, cube functions, polynomials, whatever it might be, polynomials, right? So the essential question is just simply going to be, how do I factor polynomials? All right. First things first is you got to make sure, you got to remember how to take out the greatest common factor, right? That's all part of grouping, all right? So to do that, you look at your numbers, you look at your terms, like let's say this 12x and 4, right? So we got two terms. We've got a 12x here, right? And we've also got a 4 here, right? Two different terms. What is the greatest common factor? What is the greatest number, variable, whatever it might be, that I can divide out of each? Well, 12 and 4, looking at just the numbers, 4 goes into both, right? So can I take out a 4? Yeah, and then just go ahead and divide those, right? 4 divided by 12 is 3, and there's no x's, leave the x. 4 divided by 4 is 1, and I've successfully taken out the greatest common factor. All right, do the same here, right? So if I have these terms of 5x cubed and a term of 25x squared, what is the greatest common factor, or what can I divide out of each? Well, check your numbers first, right? 5 and 25. Obviously, it should be 5, because 5 times 1 is 5. 5 times 5 is 25. But look at your variables as well, right? How many x's can I take out of each? Well, there's 3 x's here, and there's 2 here, right? So at most, okay, at most, I can take out 2 x's from each term, right? So we'll write x squared, all right? So if I go ahead and go back and divide. So 5 divided by 5 is just 1, right? You can write a 1, but let's just leave it blank, right? You don't need to write the 1. But now if I take out x cubed, right, x squared from x cubed, if I take out 2 x's from x cubed, that leaves me with 1x, right? Now divide 25 by 5 and doing the next term. That gives me 5. And then if I take away 2 x's from 2 x's, there's nothing, so we'll leave it there, x plus 5. All right, that's how you take out the greatest common factor, right? Now let's go to grouping. There's really 3 steps. You group the terms, you factor out the greatest common factor, and then you factor out the greatest common factor again. All right, so we're going to group them and then take the greatest common factor of basically each group. There's going to be 2 groups, all right? So here we go. Grouping always deals with 4 terms, all right? If it's 4 terms, or if you can split it up to 4 terms, you're set to go with grouping, all right? So first step, group the terms, all right? So I'm going to draw, just going to divide these, right? There's 2 groups now, right? Divide them down the middle, right? And then find out what is the greatest common factor of each. So that's step 1, right? We're done there. Step 2, okay? Here, this is step 1. Step 2, find the greatest common factor. Let's do the first side. Well, x cubed and 9x squared. Well, the numbers are 1 and 9, right? So obviously the only number you can really take out is 1, right? So I can only divide each by 1. There's only a 9, right? So what about the x's? How many x's can you take out of each? At most, I will be able to take out 2 x's, right? Because, you know, if I take out 2 x's here, that's going to go away. If I take out 2 here, I'll still have an x left over, right? I can't take out 3, you know, there's not enough x's in the 9x squared, right? So the greatest common factor here is going to be x squared. All right, now go back and think. If I take out 2 x's from x cubed, all right, I'm taking out from this x cubed, there's just 1 x left over. If I take out an x squared from negative 9x squared, negative 9 stays, but x squared, take out x squared, take out 2 x's, no x's left, right? And then the second step, the third step here, is I'm going to factor the second part as well, right? So 5 and 45, one number goes into both. Well, if I check 5 times 9 is 45, correct? So the greatest common factor is 5. Now, only the 5 has an x, right? 45 doesn't, so we'll leave it at that. We can't take out any x's at all, right? They're different. So if I divide 5 from 5, leaves me with an x. 5 from negative 45 leaves me with negative 9. right? So, and just so you can check, right, why it works out is x squared. If I take out that first group, right, and I multiply it back, x times x is x cubed, x times -9 is -9x squared, right? Isn't that the first group, right? We factored it. And if I check the second group, same thing, 5x. It was 5x minus 9, right? If I multiply 5 times x, 5x, 5 times -9, -45. So I did successfully take out the greatest common factor. Now you should immediately notice something in common, right? Here's an x minus 9. Here's an x minus 9. All right? That's awesome. That's what you want. So over here, I have 2x minus 9s, correct? So I'm going to write that, right, as your answer. I'm going to group up that and write x minus 9, okay, as a factor. And then take the remaining x squared and plus 5 and put them in their own parentheses. Put them as their own group. So x squared plus 5. Now I've successfully factored this as a group, x minus 9 and x squared plus 5. All right, let's do another example. All right, a little more complicated. Add a couple more numbers, but again, all right, simple steps. Let's group them, right? Let's split this up. Now I've checked the greatest common factor of each group. So the left side, 12 and 21. What goes into both of those? Well, 12 doesn't go into 21. What else goes into 12? Let's see, 4. All right, 4 doesn't go into 21. 3, right? 3 times 4 is 12. The greatest common factor should be 3. And then think, how many x's can you take out of each? Well, at least 2, right? If I take out 2 x's, you know, that's the most I can take out. The greatest common factor. So now go back and divide. 12 divided by 3 is 4. Take away 2 x's from x cubed. Leaves me with 1x. Negative 21 divided by 3, negative 7. Take out 2 x's from 2 x's, no x's. All right, do the same for the second part. 28 and 49, what goes into both? Well, 28 doesn't go into 49, obviously. So we could try 28 is 4 times 8. Does 4 go into each? No, 4 doesn't go into 49. 8 doesn't go into each either. No, excuse me, not 4 times 8, 4 times 7. 4 doesn't go into each, but 7 goes into 49, right? 7 times 7. Okay, so let's take out a 7. All right, so divide out. 7 divided by 28, or 28 divided by 7 is 4. Leave the x, right, because we couldn't take out any x's. And then negative 49 divided by 7 is negative 7. And voila, look, they're the same, right? Usually that tells you, right, what you're dividing, right? Because if you already grabbed one side, right, obviously automatically check. We know this number should be 4. So let's divide this by 4, and it usually gives you, what your greatest common factor of 7 would be, right? So just as a hint, there's an easy way to check, right? If I already got the first group factored out, the second one has to be the same. Divide it. See what multiplies what will give us that greatest common factor. All right, and with that, we're going to group these two, and then we're going to put our similar factor, right? And we're going to group the other two. And let's put them over here. Let me draw that a little better, but I'm showing you that I'm grouping these two into 3x squared plus 7. There's your answer. And that's it.